Learning target 3 and 4 are going to be together. So we're talking about creating an exponential equation, giving a graph or table, and describing the features of an equation like that. So if you think kind of back to when we did contagion, we talked about how many people a disease starts with. So you've got, 10 people infected at the start. They each spread it to X number of people, and how fast does it spread? Okay, so we're going to be looking at sort of a similar thing minus the context of a disease. So right now we're just looking at a table. And this first table is something that you've seen a lot before. If we look at the rate of change here, it goes up by 5 every single time. So it goes up at a constant rate, so we know that this is linear. And all linear equations are of the form y equals mx plus b, where m is the rate of change. So we know m is the rate of change, or 5. B is the y-intercept. So if we work this backwards, go back one more, we'll get the y-intercept at 7. So this equation would be y equals 5x plus 7. If we look over here and kind of try to figure out how much this is changing by each time, we'll see there it's changing by 50, then by 75, then by 112.5, and then we see that this is not a constant rate, so this is not linear. Okay, so let's pause on the equation for now because this is not going to be of y equals mx plus b form. So let's pause on the equation for just a second. If you see that it's not constant, one thing that it could be is an exponential equation. And if you look at this y equals ab to the x, this looks pretty similar to what we were talking about with contagion, where we said a was the number of people who start with the disease. B is how many people you spread it to, plus yourself. So I remember one of the examples that we did was like, okay, the flu starts with you, and then you spread it to yourself plus one person, so 2 to the x. And that was our equation for spreading the flu if we started with one person. So our A value is like our starting value. How many people start with the flu, or how much money do you have in your, do you initially invest in your bank account before it starts growing? Stuff like that. The B then was our multiplier. In other words, what happens for each cycle or each day or each year, something like that. So B is our multiplier. In any case, it's going to be of the form y equals ab to the x. Again, why did I write starting flu? That was dumb. Not starting flu, starting value. Sorry. Starting value. A is our starting value, B is our multiplier. Let's go back to here. Here, if we're looking at our equation, it's going to be of the form y equals ab to the x. If we first need to find our multiplier, so we know that it's not constant, so it's not going up by the same amount each time, but we need to find the multiplier. Okay, so if we're looking at 150 versus 100, we've got this equation 150 equals 100 times b, which is our multiplier. So if I then divide by 100 on both, I'll get that the multiplier b equals 1.5. Okay, and you can check that for our next set of points too. So we can check that for 225, and that should equal 150 times our multiplier of 1.5. So 150 times 1.5, that'd be 150 plus 75, which is 250. So then again, I'm just checking our multiplier b. So our multiplier is going to be 1.5. So far in our equation, we've got y equals some starting value a times 1.5, which is our multiplier, to the x. Now if I kind of work this backwards, I can find the starting value, which is at 0. If I work that backwards, I'll just be taking 100 divided by 1.5. And 100 divided by 1.5 should give me about 66.6 repeating. So now that we know that this is our starting value, A, here, I can go ahead and put that into the equation for A. Y equals 66.6 repeating times 1.5 to the x. And that's our equation there for our exponential equation of this table. Now if we're looking at two graphs, it's actually just going to be pretty much the same thing as the table. Only this time I want to first just find a couple real easy points on here. So I'm going to go with those two. So I've got the point, if I make a little table here, I've got 0, 5, and I've got 1, 10, my x and y. So if I can go ahead and write an equation for this, because I have my starting value. So A is the starting value, so I'm just going to have y equals 5 times, now we need to figure out b. So it looks like here that we are doubling each time. So my multiplier is going to be b, and then that's to the x. So our equation for this graph is y equals 5 times 2 to the x. All right. If I move to this one, now this is an example of exponential decay, and we'll get into more of this later. But whereas this is growth, like say the flu starts by having 5 people infected, they each infect 2 people. Or they each infect 1 person and then plus themselves. So this would kind of model the flu spreading, starting with 5 people. This would model something that is decaying, or getting smaller and smaller and smaller and smaller. So if we start again with our table, and we have the point 0, 10, 1, 5. We know that our starting value here is 10. So we've got y equals 10 times. Our multiplier, it looks like it's being cut in half each time. So I can do a half to the x. You can write it as 0.5 too if you want. Doesn't matter. So we've got 10 times a half to the x, and that is our equation for this graph. Again, all I did is really just make a table out of it and then repeat the process. So one thing that this can be really useful for is, and we talked about this in class a little bit, but if we want to know, let's go with this one on the left. If we want to know maybe the spread of a disease at day 500, okay, we could go through and go times 2, and do that 500 times. What the equation is really helpful for is it will save you having to do this 500 times. Okay, I know that there are some of you Brett, that think that this isn't very hard and that it won't save you much time. Whatever, not going to argue about it. But doing the equation, I think, is going to be a lot easier for you. So take this y equals 5 times 2 to the, and now I'm going to just plug in a 500 right here. You can't do this on your standard calculator, but if you have like a scientific calculator or a graphing calculator, this is just really easy. You just go through, you do 2 to the 500, multiply it by 5, and that gives you your y. And it's a lot easier to figure out at day 500 the spread of this disease rather than having to multiply it by 2 500 times. So for your before class, here you've got x equals 0, so your starting value should be pretty obvious from there. Figure out your b, figure out the multiplier. Okay, and if you need to go back and look at a couple examples ago, go ahead and do that. But basically you're looking for your starting value, your multiplier, and that can help you figure out the equation.